Yes, my privilege to welcome you all here today. We're going to enjoy a webinar presented by MSA, the safety company, one of the biggest brands, if not the biggest brand in the safety industry worldwide. And we're here today to learn about a very important, sometimes confusing subject that we're going to clear up a few things about for you to take back to your workplaces and protect your workers and your teams. Why am I here? Well, the webinar is being presented by MSA, but Bay Publishing, the publishers of Health and Safety Middle East magazine and Health and Safety International magazine, we're hosting the webinar today. And so I'm going to be introducing that, and our speaker will be with you in a couple of minutes. So the subject of our webinar today is fall protection, and more specifically than that, fall clearance. We're going to be looking at what that is, why it's important to get it right, and how to prepare for working at low heights, which might sound counterintuitive, but does bring about very specific problems and things to be aware of. So we're going to look at that today. To give you a bit of background, low height working scenarios cover things like scaffolding, erection and dismantling, industrial plant maintenance, loading bays, and trains. There are lots of instances where available fall clearances are insufficient for a conventional, normal fall protection solution. So that's what we're going to be looking at today. Falls from height, sadly, remain the single biggest cause of workplace fatalities, and getting our fall clearances right is a big part of improving this. So in our webinar today, MSA are going to take you through the main factors that lead to fall clearance calculation. They're going to explain the considerations and choices that can make a positive difference to the safety of your workforce and get them home safely at night. So our speaker for today is Alfonso Fernandez. He's a marketing manager at MSA. He's had more than 15 years of experience in the PPE industry. He really knows his stuff, and we'll listen intently to him. His experience is focused on fall protection applications for working at height, and he's absolutely passionate about delivering innovation that can make a safer world. So let's hear what he has to say over the next half an hour, 45 minutes or so. Importantly, if you have any questions throughout the webinar, note them down and make sure that you contact Alfonso either at the end of the webinar on our question and answer forum that we'll have a little bit later, or on the contact details that Alfonso will show you at the end on his last slide. So please get in touch with MSA, ask your questions, and get in touch with them, connect with them on social media. So without further ado, let's hand over to Alfonso as he takes us through our webinar today.
Thank you, Nigel. It's my pleasure to be here with you all today, and I'm delighted to guide you all through the topic during the next hour. Again, in case of questions, don't hesitate to share with us, and we will try to review them at the end of this webinar. Just before starting with the topic, let me give you a very quick introduction to us at MSA if you have never heard of us before. MSA Safety has led the charge for workplace safety for over 100 years. The company was established in 1914 after a horrific workplace tragedy in Jet Mine, West Virginia, where a methane gas explosion resulted in the passing of 80 miners. Following the tragedy, John T. Ryan Sr. and George Dyke went to one of the world great thinkers at that time, Thomas Edison, and they invented the first electric cap lamp, which over the next 25 years reduced mine explosions by 75%. In the decades that have come and gone since, MSA has developed countless safety innovations with a clear mission in mind: to see that men and women may work in safety, and they, their families, and their communities may live in health throughout the world. Today, our global headquarters is in Cranberry Township, Pennsylvania, USA, And we are publicly traded on the New York Stock Exchange with revenues of over $1.4 billion. What differentiates MSA to others is that our sole business is safety products. Our strategy is to be best in class for each category. Fall protection has been one of our fastest growing ranges in the last decade, with our centers of excellence located in the US and the UK. It's in these sites where lots of design work takes place for new work at height innovations, and where we have the capability to test our products to ensure that they perform beyond local standards. You can see on this slide an image of our testing facility in the UK, and you'll actually see the one in the States in a few videos we will share later today. We also have a Middle East training and technical center located in Abu Dhabi. This facility is supported by a dedicated sales and design team to assist and execute projects locally. MSA has 6 core products, those being fixed gas and flame detection, portable gas detection, industrial head protection, fall protection, breathing apparatus, and specialist fire and rescue helmets for first responders. We have a local presence in over 40 countries with manufacturing facilities in 15. Being fall protection the focus of today's session, let me begin by sharing some pretty startling facts about falls from height. We are making major strides in safety, but the fact is falls still happen. As the most recent statistics show, once again, we still have a strikingly high number of fatalities from falls from height. This is happening despite all the efforts organizations like yours and ours are putting forth to stop it. And this is happening everywhere, even in advanced economies, in places with the highest levels of safety awareness, in workplaces with robust systems, and in countries where laws enforce protective measures. Unfortunately, the reality is that even now, thousands of workers become permanently incapacitated as a result of workplace falls from height. Due to this reality, many of the countries we are running campaigns from time to time to spread awareness of the risks and hazards when working at heights. This is not a happy topic to talk about, but many people are doing their best to improve the safety of the workforce. And I am proud to say that this includes all of us here today. As an introduction to the topic today, let me tell you a short story of what could be one of our fellow colleagues, one of our relatives, one of our friends, or one of our neighbors. This short story is focused on a day in the life of Ali. Ali here is a construction worker who is part of a team of scaffolders for a large contracting company. The company is working on an expansion project on their client's premises, a national utility company, a client of great importance and reputation. Ali is an experienced scaffolder and is good at what he does. At work, he wears his usual body harness and lanyard, or safety belt, as his supervisor calls it. This is mandatory safety equipment, and they are not allowed to work without these work at height PPEs because of strict HSE policies of his companies and the client's requirements. Today, just like any other day, he gets up in the morning and heads off to work. He's feeling a little tired today, and his back is hurting a little. He ignores it and goes to work anyway. It's 38 degrees Celsius, hot and humid, but nothing unusual. Ali gets to work. As he's busy erecting the scaffold at nearly 3-meter height, he suddenly feels dizzy and feels the world go upside down and around him. When he will wake up next, he will be in a hospital bed in terrible pain. What happened? Turns out, when Ali felt dizzy and lost his balance, he fell off the scaffold at 3-meter height and hit the ground. Even though he was wearing a safety belt, it did not stop him from hitting the ground. As a result, he fractures his wrists and both his kneecaps, which he used to stop his fall, Even though he will not be able to return to work for a long time, he is lucky his fall didn't lead to a permanent paralysis or a fatality. The biggest question, apart from several others, was why did the safety equipment not stop Ali's fall? The reason, it turns out, was lack of fall clearance. This is one of the hidden hazards that is often overlooked while working at height, and that puts skilled workers like Ali at risk of injury every day. And this is the reason we are here today. So we will use today's opportunity to speak about fall clearance, how to calculate it, identifying the factors that are affecting the calculation, and how to influence them. Let's start defining fall clearance and why it should be on top of our minds. So, what is fall clearance? Now, here is a picture of a worker on an elevated platform. Fall clearance is about the distance between your working platform and the ground or obstruction below. You have enough fall clearance if, when you fall from the platform, your fall will be arrested before you touch the ground or obstruction below. You do not have enough fall clearance if, when you fall from the platform, your PPE do not stop you from touching the ground or obstruction below. Fall clearance is the distance needed to safely arrest a fall from height and must be calculated as part of a risk assessment for work that has potential to expose workers to free fall arrest. So, how is fall clearance calculated? Let's first understand the two events that happen when someone falls wearing fall protection PPE. The first thing that will happen is the worker will free fall during the influence of gravity. Nothing is stopping them at this point, since the energy absorber in the safety lanyard has not been activated yet. The second part of the fall will be the deceleration, when the worker will be gradually brought to stop after activation of the energy absorber in their safety lanyard. What does it mean by activation of the energy absorber? It means that the force of the fall will be used to rip open the webbing inside the energy absorber, which will make the energy absorber open up and elongate. Without this energy absorber, this force of a fall will impact the body and cause severe injury or death. Now, this activation and opening up of the energy absorber creates a problem at low heights because it eats away at the fall clearance required to safely arrest a fall. Simply put, the more you are allowed to fall and the longer your safety lanyard, the higher the fall clearance required. Let's consider this scenario where Ali is using a regular 1.8 meter long safety lanyard, which he has connected near his shoulders. He's working at 3 meter height and suddenly he falls. What would be the fall clearance needed from his connection point and the fall clearance from the working platform? As we discussed on the previous slide, he will free fall approximately 1.8 meter. Then his energy absorber will get activated and expand to add 1.2 meter length, distance B here, and then we need to keep in mind his height, let's say 1.8 meter, distance C here, plus a safety margin of 1 meter. Anyway, why this safety factor? Because this is not exact science. Plus, there are some factors we are not taking into account in the calculation, as we will review later. This means that from the working platform, Ali will need a safe distance of about 4 meters, and from the connection point, a distance of 5.4 meters. This means for someone like him, who is working at a height of 3 meters, there was not enough fall clearance. And so the scenario it was showed, was probably the best case scenario. It's very common not being able to connect at your shoulder level or higher, and you need to connect your lanyard at your foot level. And now I must warn you that NC approved lanyards will allow you for 6 feet free fall will not allow you connecting at the foot level, since the free fall will be more than 6 feet. This is because the more a person can free fall, the more energy the absorber will need to dissipate. The other hazard, of course, is the drastic increase in fall clearance that will be required in this situation. Let's have a look. In this scenario, he will free fall nearly 3.6 meters. Then his energy absorber will get activated and expand to at 1.2 meter length. And then we need to keep in mind his height, let's say 1.8 meter, plus the safety margin of 1 meter. And this means that from the working platform, Ali will need a safe distance of about 5.4 meters. And of course, this means that for someone like him, who is working at height of 3 meters, there was again definitely not enough fall clearance. Just so all we get the feeling about the distance required in the event of a fall, let's have a quick look at this short clip here. We recorded in our testing facilities in the States. It's a very short one. We are seeing a dummy with a harness connected to a lanyard. And this lanyard is connected to an anchor point at foot level. Watch out the height required by the fall. Amazing, isn't it? Look at this. However, as you know, calculating fall clearance and trying to keep it within the limits is the last resource we have. So, before diving into details, let me start by reminding you about a few simple steps you can take to get your fall protection right. This is very much linked to the hierarchy of control. First, ask the question, can we avoid having people working at height? If you really take the time to think about it, the answer might be yes. For example, windows or gutters can sometimes be cleaned without the need to climb up to the roof. Or if you are in the design stage, can you design out the need to work at height? For example, can you plan for machinery that drops down to the ground level so maintenance can be performed on the ground rather than at height? Perhaps inspections can be done with drones rather than with a person working at height. While you may not always be able to avoid work at height, it's important to consider all the realistic options and do what you can to eliminate risk. Next, evaluate whether you can deploy what is known as collective fall protection. Collective fall protection is simply fall protection that doesn't require the user to undergo any special training for the job. For example, a handrail, building parapet, or skylight cover are all considered collective measures. Typically, collective protection allows you to protect a number of people all at the same time, saving both time and money. And next, take a look at how you can best protect the worker based on the environment and the job. This is the point within the hierarchy where you may need to introduce a harness to provide safe connection of the user to an anchor point. Also within this protection of the worker is where you can differentiate the PPE based upon the risk. A work restraint system, for example, restrains the user from getting into a position where they could potentially fall. This working method is definitely worth to explore if the distance to the ground is very limited. A fall arrest system, on the other hand, means using a longer lanyard to enable the worker to get into a position that he has a greater potential for falls. Naturally, this is the highest risk approach and will require means for potential rescue if the user should fall. Now, let's translate that hierarchy into site-based guidance. Here we have a look at the steps you can take to ensure that you get fall protection right the first time. First, avoid the risk if you can. What measures, tools, and technologies can you use to prevent operatives from getting to a place where they have to work at height? Second, understand the risks on site by taking the time to get to know both the approaches and the stakeholders. How will equipment be accessed? How will it be maintained during normal operating conditions? What about turnarounds? Third, select the correct fall protection equipment by partnering with specialists who understand best practices across a range of industries. Look for a partner that offers innovative solutions and bespoke designs to solve your problems, a problem they know, understand, and have experience with. Fourth, make sure your equipment meets current standards and legislation. Standards and legislation change over the years, and it's your job to keep up with those changes. For example, prior to 2018, you were allowed to pull the cable out of the wire and on a vertical fall arrest system on a ladder to get your harness attachment device to pass through the brackets. Under current standards, now you cannot interfere with the cable, plus the device must be able to pass through the brackets hands-free. And fifth and finally, be sure you have a regular and thorough safety training program in place. You'll reap both tangible and intangible rewards by ensuring that your workers are trained in the correct use and care of their PPE. All right, so we are now at the point that we understand how to calculate fall clearance, why it is important, and we know that exposing our workforce to it should be the last resource. Unfortunately, sometimes there is no other way. In fact, one of the most common questions we are asked is what measures need to be adopted when the workers are faced with low fall clearances. Low ground clearances can occur in a variety of applications, as Nigel mentioned before, including loading and maintenance bays, machinery parks, and gantry cranes. In fact, low ground clearances can be found just everywhere. So let's now then unpack the factors that are affecting fall clearance. We will start describing how the anchorage point position is key in the fall clearance, which is bringing to us the so-called fall factor. Probably this word sounds familiar to you, right? The fall factor is the ratio between the height of the fall and the length of the lifeline available to absorb that fall. Which means that if connecting overhead, the fall factor will be 0. At fall factor 1 describes a fall where the system has been attached to an anchor point that is at least as high as the shoulder blades. And fall factor 2 means a connection at foot level. The lower the anchor point, the more available lifeline will be available in case of a fall, and therefore the longer the free fall. Or which is the same, the higher the anchor point, the shorter the free fall. By limiting the free fall, we will also limit the energy deployed, and the absorber will need less distance to arrest the fall. At this point, you should notice that typical US certified connecting devices are designed to be used in fall arrest systems that doesn't exceed a 6 foot or what is 1.8 meter free fall. So clearly keeping the anchorage point overhead looks like a good idea. Clearance will be limited and the connecting devices will not present issues. The problem lies in the fact that many times it's just easier to anchor below the harness dorsal D-ring. This means exceeding free falls of 6 feet. Due to this, manufacturers like ours have designed products that are equipped to experience free falls up to 12 feet. This can be fine if end users are trained so that they understand the limitations of their equipment and how to select the correct equipment for the task with which they're involved, and if they have enough fall clearance. But if fall clearance is one of our challenges, we will need to come up with an idea to keep the anchorage position as high as possible. As an example, here is a diagram showing how the anchorage position affects one of our energy-absorbing lanyards. You can see the higher the anchorage point, the shorter the clearance needed. However, it can also happen that the worker is not working close to the anchorage point. And this is very common indeed, because most people don their harness and lanyard and give little more thought to their fall protection. They play the lanyard out as far as they can in any direction they need to go. And if a fall should occur, they would swing like a pendulum back towards the anchor point. In the process, they could strike with great force the structure they are working on or another nearby structure. A worker could certainly be working in an area where there is no other structure to strike, and that's good news. However, the swing fall would have a side effect in case of using a retractable device, as it increases the free fall. Remember, retractable devices do not recoil during a fall, they just lock. This is very important to remember if using big SRL blocks, right, connected to a non-mobile anchor point somewhere, like a D-ring below an I-beam. If the user is moving around, there will be more and more lifeline from the anchorage point to the user. Lifeline that will result into more free fall. As an example here, we have a diagram showing how this is affecting one of our SRLs. You can see the farther the anchorage point is from the working zone, the more clearance is required. So, what should you remember about the anchorage point position in order to keep clearance as short as possible? The first thing is to ensure that the anchorage point used is overhead. Of course, installed in a location where the worker isn't put at risk in order to attach to the anchor. Is there any issue if using an anchorage point that is not overhead? No issue if there is enough clearance. Imagine you are on top of a roof in a building. There is usually enough clearance, so an anchorage point at foot level is fine and a common solution. But if your crew is working in an application where you are running out of clearance, ensure a suitable overhead connection. The second thing to limit or eliminate, if possible, is the swing fall, not only for the risk of hitting a structure, but also for the risk of hitting the ground, as we explained in the previous slide. The second factor affecting clearance we will review today is the nature of the anchorage point. It can happen that the anchorage point can displace under the load of arresting the fall. This process is called deflection and most commonly occurs with a rope or wire cable. Because they are flexible materials by nature and they are installed by being placed under tension. Deflection doesn't typically occur if the anchorage point is rigid like an I-beam. The additional clearance due to deflection will not be the same for everyone because there are many variables that factor into deflection distances, like the weight of the attached worker, the type of lifeline, how it's installed, and so on. So, in case your crew is working in low height applications, the first suggestion would be to prioritize the use of non-flexible anchor points. But overhead and close to the working area, as we reviewed, of course. So, this is starting to get complicated, isn't it? The fact is that non-flexible anchor points are not always possible to have around. In order to get an anchorage point that is allowing a certain mobility while working, your workforce would be in the need of deploying a temporary horizontal lifeline. But be aware that deflection is usually quite large in these devices. If you go through the solution and you have an issue with clearance, ensure you are using at least a quality lifeline. As example, MSA, we have developed recently a temporary horizontal lifeline with tensioners that are indicating to the user that the lifeline is correctly tensioned. So at least we are limiting the risk of misuse. If your workforce is using once and again the same station, perhaps the best solution would be to install a fixed Anchorage system. These Anchorage systems are engineered solutions, many times customized, that help ensure that freefall distances are suitable, or should be. As an example, MSA has developed a number of horizontal lifeline systems, employing a customized analysis for each project, calculating important values like cable deflection or dynamic arrest-free distance. And last but not least, also adapting this system to the loading capacity of the available structure, which is an additional challenge for these systems. If you choose a solution like this, be aware that many manufacturers or installers of fall protection systems are incapable of predicting or calculating loadings to an exact point. This is not only leaves you with questions, more questions than answers, but it could result into taking no safety precautions whatsoever. And at this point, we know that our choice in terms of where to anchor and what anchor to use can affect the clearance. Let's now focus on the connecting device. The connecting device will greatly affect the lifeline we have between the anchorage point and the harness. In general, the shorter the lifeline used, the shorter the freefall will be. In a typical application, the most popular connecting device would be an energy-absorbing lanyard. The choice of lanyard model is then adapted to each workstation. The longer the lanyard chosen, the more freefall distance we will need to consider in case of a fall. However, there is another choice in terms of connecting device, a retractable lifeline, which is a device that automatically retracts the lifeline into a housing unit on a similar way as a car safety seatbelt does. The beauty of a retractable lifeline is that the worker is always using the shortest lifeline possible between the harness and the anchorage point. And this is really changing the game, because not having unused lifeline around is really limiting the freefall, which in turn is limiting the energy deployed and therefore the length extension the energy absorber needs. The result is a drastic reduction of the clearance needed. Retractable devices are available in very different shapes and forms and are today very popular for their enhanced safety in many sites in the world. Surely, they have downsides versus lanyards as their weight, but their contribution to safety is unparalleled. So we can see the difference between using one or the other connecting device. Let me share with you a couple of tests in our facilities in the States. One with a lanyard and one with a small self-retracting lifeline, both connected to the pack tiering level, so about 2 6-feet freefall. Let's start with lanyard and have a look, especially on where the fall stops. Look. Just a repetition of the same, different angle, but look at where the fall stops. And this is just connecting at tiering level. All right, and now let's see what happens if using a retractable device. You will see that the retractable device stops the fall much earlier than the lanyard. This is the retractable device. Look, the body has not even fully descended to the next level, but it's keeping half of the body or more into the same level. This means the risk of hitting the ground is much less, and in case of a fall, it could be much easier to rescue. So, in case you are troubled by clearance, don't hesitate and choose always a retractable device. And look now at this picture. It's a busy train depot in the UK with a technician working on the pantograph. The roof of the coach is about 3 to 4 meters above the platform. An engineered lifeline allows an overhead connection with good mobility and limits deflection. The retractable device anchored overhead is making the rest of the job, and therefore the worker would be safe if falling from the area he's working on. Another factor contributing to the fall clearance is the user's weight. The weight typically includes the weight of the employee, their clothing, tools, and equipment. In case of a fall, all this weight will contribute increasing the energy generated. It's important to understand that there are certain weight limits for fall protection equipment. In general, OSHA and NC allow for a maximum capacity of 310 pounds for fall arrest systems. CE products are tested to 100 kilo only, unless marked differently. As you can guess, the heavier is the load, the more energy generated in a fall event. This will translate into a larger deceleration distance, and in case of using flexible anchor point, a higher deflection. If clearance troubles you, of course, you can ask your workforce to minimize their meals, right? But you can influence on the amount of weight they are carrying with them and keeping an eye onto how many workers are using the same Anchorage connector. It's not uncommon to see various workers using the same lifeline. Deflection can also cause a pull on the lifeline and could potentially cause other workers who are attached to the same lifeline also fall and travel to the center of the lifeline. This occurs when one worker falls on a flexible lifeline and their body weight shifts to the center of the overall lifeline. And then instead of one worker falling, there could be several workers who fall as a result of the deflected lifeline. While this is allowed, as you may imagine, this is causing the deflection to reach an alarming limit. If you are troubled by the clearance you have, don't hesitate to limit the number of workers using the same lifeline. At this point, we have reviewed most of the factors affecting clearance. However, there are 3 more details I would like to bring to you today so you can have the complete picture. The first of the so-called others is the harness stretch. In case of a fall, the harness webbing is elongating due to the energy generated. This elongation, which could reach around 30 centimeters maximum, is not usually taken into consideration as a standalone factor for the fall clearance. But it's more assumed within the 1 meter safety factor that is added into the calculation that we were just mentioning before. However, pay attention around the type of harness your workforce is using. Not very common today, but there are still a few of harnesses with elastic webbing being supplied into the market. Trendy a few years ago, this type of textile can elongate more than usual, so thoroughly check the details if it happens you are using or interested in one of these. The other thing you need to pay attention to is ensuring your workforce is donning the harness correctly and that the adjustment stays acceptable as long as they are on the job. A harness that is not correctly donned is dangerous and can influence the fall clearance very seriously. The second detail I would like to bring to you today with these other factors is a popular accessory. And I am very sorry to say this is popular. An accessory that is so common that it's not only supplied as an accessory, but sometimes it comes as part of the harness. This accessory is the D-ring extender, a lovely piece of webbing that allows the worker to easily reach the connection of his strap and connect to the Anchorage device without an act of contortionism. For those of you that have tried to connect a snap hook to your back D-ring, you know what I mean. Well, great in paper, but the fact is that this accessory is an important contributor into an additional clearance. not to mention about the additional free fall that could expose the lanyard to more energy than what it was designed for. Since this piece of webbing is directly adding a free fall distance, this accessory should come with a warning label, but not always are. The problem is that these accessories are so popular today that everyone is seeing them as a standard, and they should not. If fall clearance is troubling you, keep an eye into these extenders. And the last factor to consider in the others category I would like to mention to you today are the obstructions below the working area. They are not affecting the clearance from the user's side, but from the ground side. The more obstructions you have, the shorter the available distance your workforce will face. There is usually a lot of equipment being moved around in busy workplaces. Just ensure they are not directly below the workers if the distance is limited. This means a lot, right? And it is. Once you calculate the available distance, you will need to consider how the work is done, where to anchor, how the anchor looks like, if it deflects or not, what is the connecting device, and how long is the available lifeline. If there are accessories used, how much weight your workers are carrying, and many others. Probably you will need to dive into various manuals, checking the clearance required for each of the products you use. At MSA, we know this is challenging. And not only that, but we also think it's not safe, as there are many angles that could be misinterpreted or overlooked. Due to this, we have created clearance charts as the one that is being shown now on the screen. This is part of our chart for our new temporary lifelines. We have made the calculation based on the span length, the number of users per line, and the type of connecting device, and taking this to the maximum weight allowed. So you can easily check the clearance for your case and also find out how it would change if you are using a different connecting device or increasing or decreasing the span. Likewise, if you choose for an engineered customized system, we are also taking the calculation on board, as I was showing you previously, so you have all the data you need for your specific case. So, as we begin to wrap up our session today, allow me to summarize the learnings from this session. First, remind yourself to continuously assess and monitor safety risks as per current legislations. Second, no matter if you are running a company or a department, or an HSE manager or a field technician, always follow a 360-degree approach to fall protection. Also make sure that even quick maintenance operations are performed in the safest possible way. And third, if you can't avoid works at low height, first, check if working in restraint is an option. And if it's not, then check that the best connection is chosen. Select the right anchorage point for your application. Always choose the retractable device. Be careful with mistakes such as harness donning, and be careful with accessories like the D-ring extender. And finally, ensure that there are no obstructions on the ground. Because all's well that ends well. It's in our reach to help colleagues like Ali. And last but not least, when considering your fall protection program, policies, and PPE, partner with an expert like us and many others. In fact, our technical team is ready to support you. Contact us and we'll follow up as quickly as possible. And as we are wrapping up today, I would like to thank you all for attending. My hope is that you have a better sense of why fall clearance is important, how to calculate, and what factors are key to consider. I will be now happy to answer any questions you might have, or if you prefer, feel free to contact me at the end using the contact details that I'm sharing on the screen. MSA's experienced staff would be happy to provide you solutions to make any task within your organization safer. All right, let me have a look here at the questions and let's see if I'm seeing something. First question we have here says, while measuring fall clearance, is the space covered by stretching of the fall protection harness calculated? Yes, I think that I answered this within the slides. Definitely. That is calculated, though, as I said before, usually that's maximum of 30 centimeters, which is taking into consideration in the 1 meter safety factor that we are applying. So unless we are using a specific harness that allows higher stretch, then it's something that we should not really have a look at. Let's have a look at others. Says, I'm working in an electrical company where we are required to work on electric poles. Can you please advise the best fall protection available for the pole-related works? Actually, when working on poles, if you mean by pole, the wooden poles, and correct me if I'm wrong, because otherwise would be like, electrical pylons, the big, high electrical pylons. If those are wooden poles, usually the kind of work there is not actually fall arrests, but work positioning. You have a work positioning lanyard working across the pole, and then you're climbing, positioning, so you have your hands free and working there. It's a tricky task, to be honest, and yeah, it's something challenging, definitely. Good. We have another question here. Says, we have noticed that sometimes a class 2 retractable device requires more clearance than a class 1. Is that the case, and why? Actually, great that you have noticed this. For everyone here in the audience to know, this classification refers to NC. SRLs for use with anchorages at or above the dorsal D-rings are classified as 1. While SRLs for use with anchorages above or below the dorsal D-rings are classified as 2. These classes ultimately explain how much the free fall the unit can handle. To add a little bit more of complexity, these classes are actually replacing the class A and B according to NC. With the old standards, there were multiple performance requirements depending on the class. It was super complicated, which explains that actually that overhead units had a shorter clearance than those classified as B. And as manufacturers have been updated their old product range, you will continue to see this difference if they are still within the limits tolerated by the new standard. Overall, as we have been suggesting today, have always, a look at the charts if you have a clearance challenge around your place. All right, let me have a look more. When we do not have anchor point above and only ground level, which lanyard do you suggest? This is in case, we, in the terms of facing an anchorage position, this is the worst case scenario. We are connecting at foot level. So at least we should ensure that we are using the best possible connecting device that we have available. And even though we will need to have a look at the charts and ensuring that the clearance we have below our feet is enough. I would definitely go for a retracting device, not lanyard, because the lanyard you'll have a lot of unused lifeline around and will increase the free fall. So choose a small retractable lanyard, one that is allowing you to work at ground level, because many of them are not available, so you can utilize them and connecting at foot level. And if you are connecting at foot level, always ensure if you are going to fall over an edge. If you are going to fall over an edge on top of a fall factor 2 certified retractable, you'll need it leading edge certified. I would strongly suggest you to take full factor 2 leading edge certified small retractable device. Good. Another question here around. We are using mobile elevated working platforms. Is there a minimum height for this application? Many thanks for the question. And tricky one. Mobile elevated working platforms are a case study on their own. Though many of the topics reviewed today apply for this application, I have not been diving into the details that are making mobile elevated working platforms unique. One of them would be the risk of the platforms to destabilize in case of a fall due to the energy generated. In many countries, fall protection is required if working on platforms that can move while being on the top, and sometimes even the static ones, the ones that are only going up and down. This is due to various risks when working from those platforms. One of them is the risk of overreaching. And another serious one is the catapult effect. When someone moving the platform from the top, they are on the top of the basket and they are moving the platform. If the platform is hitting something, then the basket is moving up and then the catapult effect happens. Generally, many legislations are requiring to work on restraint on the platform. If you are choosing this solution, work restraint, actually, there is no minimum height because a fall would never happen. However, this is the theory, and I would personally be very careful with the issue of misusing the work restraint lanyard, as a fall without an absorber would be very serious for the worker and would allow a lot of energy pass through the lanyard to the platform and destabilize the platform, and the platform can fall together with the worker. If your legislation allows, we always recommend the use of a small retractable device to limit the movement inside the basket and arrest the fall in case of happening. If this is your choice, always have a look at the clearance charts provided by the manufacturer. And above all, ensure that the retractable you're using is tested and certified so it can be safely used on mobile elevated working platforms. There is no international standard for this, but actually the Germans have a dedicated standard and they are testing these units. All right, another question here. What is the life period of a fall protection device? Not especially something related to fall clearance, but very common question indeed. Life period, it really depends, on the materials used on the products. You will usually find out that information in the manual provided by the manufacturer. If there is a life period, the manufacturer is obliged to show that period in the manual. And the manual is usually approved by the notified body in charge of the certification. So you'll find out that period there. In case of textiles, something like harnesses or lanyards, life periods are usually, ranging from 5 to 10 years, maybe something a little bit more. That's the life period of something that is, that is in working condition, because you'll definitely need to perform period examinations from time to time. And if the lanyard or the harness is not passing that inspection, regardless of what the manufacturer is saying, you'll need to dispose of the equipment because equipment is worn out and you'll need to replace that one. In case of retractable devices, if those retractable devices are based on webbing, usually the same lifeline life period applies. You'll find that out as well in the manual. In case of retractable devices that are big, the big things made of cable, they are usually allowing a longer lifeline, and sometimes they don't have any specific lifetime. So as long as they pass the periodic inspections, they are fine to use. Even some of them are serviceable, like ours. So you can actually keep that SLL being utilized one and again. And whenever there is a part that needs to be replaced and is identified through the periodic inspection, you can replace and utilizing this again. All right, good. More questions around. I think we are fine. So I would like again to thank you all for attending today. Really appreciate that you have been here with us. We have been so happy to show you a little bit more about the fault clearance and bringing the fault protection topic to you all. Appreciate it again and wishing you all a great day. Thank you all and see you soon.